Hello, everyone. Welcome to our webinar. So I really appreciate your time spent to join our webinar today. Hopefully you will get some information from here. Topic is Minitab Statistical Software Measurement System Analysis. I'm Nur Sulawati. I'm the Technical Support Specialist at Visit System. Visit System are independent local and representation for Singapore, Malaysia, and Batam, Indonesia. Okay, before we get started, I have some housekeeping item. If you have question during presentation, please type them into the question box in your control panel. You may send any time throughout the presentation, but I will address them during Q&A session at the end of this webinar. Kindly ensure that you have connected to audio speaker. Please fill out our survey before you exit the tab. This survey will help us to improve the quality of upcoming webinar. For your information, this webinar will be recorded and therefore it will be set listen only mode to avoid interpretation to the audio recording. So this recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, so for those are new with us, Minitab was developed in 1972. So today, Minitab in the market for 50 years. Okay, so Minitab Statistical Software is a software package for statistical analysis. Since in the Minitab itself, we have others product, but today we focus on the Minitab Statistical Software. So variety of the statistical tools available in Minitab Statistical Software. This software, it will be powerful statistical software since everyone can use, whether you are statistician or non-statistician or data sciences or non-data sciences. So this one is some of the tools are available in Minitab Statistical Software. For example, for quality side, Minitab have a measuring system analysis for today's topics. So we have a gauge study and then we have attribute algorithm analysis. I will go after this. And then we have also control chart, maybe upcoming webinar for the control chart. And then we have also capability analysis. And then we also have something like acceptance sampling. And then we have the tolerance interval. So for those are coming from the, always ask about the SPC or SQC. So we cover for the SQC part since we have a acceptance sampling. Okay. And then we have also something like for reliability engineering. With the latest updating, Minitab 21, we have a new added tools for the reliability engineering. We call it a COP regression. So might be you interest on this one. So if let's say you want more on this, you can contact us for the COP regression. Okay. And then, of course, once our process stable and capable, the next step, it will be followed by the optimization. Okay, if the objective to optimize the process, maybe DOE or design of experiment, it will become in the best tools to do optimization. So in the Minitab, you able starting the journey to design of experiment from the create design itself. Okay, you create the design itself, and then you do the analysis, and then after that you can do the prediction and optimize the response itself. Okay, so what we have in the DOE, we not cover for the full factory only. We also have something like response surface design. We also have the Taguchi design and so on. Okay. And then, okay, so without experimental data, without the DOE design itself, but you have a lot of historical data you already have right now in your collection. So maybe you're able to do prediction with this modeling, something like we call statistical modeling. From the traditional one is something like regression itself, binary logistic regression, partial least square regression, and so on. But just want to say to give the information, Minitab already added, we call it the decision tools, or we call is classification and regression tree tools. So maybe before this, you're only use the regression, but maybe you can try with another modeling method, is we call it the cut. And then we also have something like time series analytic, is something like a ARIMA model, if let's say your data is a time based, okay? And then of course, with the latest Minitab 20 from the Reposibility, we have a new editing visualization. Okay, if let's say you have a big data set and so on, so visualization must be to help you see or insight from your data collection. Okay, and then this one is for the process validation. Actually, all the tools inside the process validation are available in Minitab. Okay. And then with the complete tools for analysis, so our customer coming from various of sector include the manufacturing staff, academicians, services, logistics, and so on. So what we know for the manufacturing staff, we have big sector. Is it something like automotive, maybe it's pharmaceutical, maybe something like electronic, and so on. So we have a lot of type various sector our customer use the Minitab. Okay, and then today is our objective today is measurement system analysis. I think this topic is a core topic, especially for those rely on the data to make the decision. Okay, but with this limited only 1 hour, so I can say that only 1/3 from the whole topic I will cover on this webinar. Okay, so if you interest more on this topic, we encourage you join our training, whether in-house or public training. So our agenda today, actually, we have something like we just play around with the Gage R&R. And then we have something like attribute agreement analysis. If let's say your data is your assessment or your appraiser, something like attribute yes or no, something reject, not reject, or something like level 1, 2, 3, and so on. It's a rating and so on. And then we go for the assistant. Okay, so hopefully we have enough time to cover all this one. Okay. So let's retry with the simple concept first, okay, before I go to the Minitab itself. Okay. So measurement system analysis is a method determine whether a measurement system is acceptable. Okay, so measurement system include measurement device, your device, okay, measurement procedure, and then your operator that affect to the measurement of a part. So maybe your measurement can be we call it continuous response variables. So be in the continuous response variable, something like the length, the height, the weight, something that one. So the one is we assess or determine to the amount of the total variation that is from the measurement itself. Okay, and then maybe your measurement can be something like attribute response. You want to evaluate the consistency or we call and accuracy of the appraiser itself. So today we just simple analogy in the data type we have two, continuous and attribute. So same scope for the measurement system itself. We have the continuous response and then we have the attribute response. So different type of the data, we have different tools to take care of this kind of the analysis. Okay, the objective is still the same, but just different tools only. Okay. So our goals in the MSA actually to assess the error in the measurement system itself. So maybe the error can be partitioned into specific sources. We call is one, the first one is accuracy. And then the second part is the precision. So for the accuracy actually is the how close your measurement to the true value or how close your measurement to the target value. Okay, so the difference between the part measure and the actual value. Okay, so if let's say you want to assess on the accuracy is maybe in the mathematical equation, you can get from the difference between the part measured and then the actual value. So the component you can assess on the accuracy side is a bias, linearity, and the stability. But today we not focus on the bias, linearity, and the stability. Okay, so we have another sources is we call is precision. Okay, so precision is something like how close your measurement are to each other. Okay, so the precision is not how close measurement to the actual value or target value. It's how close the measurement to each other. So it's this keyword each other, meaning to say that it's a repetition. Okay, it's coming from your repetition. So if let's say only one measurement, so maybe it's not good to measure the precision, to look on the precision. Okay, so the precision inside the variation when the same part is measured repeatedly with the same device. Okay, so the component inside the precision yang you able to measure it is the repeatability and reproducibility. Okay, so I think this figure is something like, I think we at the secondary school already know and then see on this figure. So something like we won, okay, we won is accurate and precise, but maybe our process can be precise but not accurate on this target. Okay, this one is precise on this value, okay, on this area. Okay, not accurate since it's a far from the target. Okay, this one is the accurate since one of the dot or of the measurement is in the target in the red color. Okay, and but it's not precise. This is a round figure of this target. Okay, so this is neither accurate or precise. So what we want is the accurate and precise. Okay, maybe it's difficult to get, but no worries, you can assess on this part. Okay, so in this tree diagram, so we try for the process variance itself, we split into the two terms. We call it the part-to-part variation, and then we call is the another side is measurement system variation. So in the measurement system variation, actually we assess on the accuracy and then we assess on the precision. So for the accuracy, we have a bias, we have stability, we have the linearity. And then for this case, for the precision, we have the repeatability and then reproducibility. So after this, we go on this side of the precision. So if let's say your aim to know more about the accuracy, not in this webinar, I know we'll cover on this accuracy, bias and the linearity and the stability. Okay, so we go for the Gage R&R. Okay, Gage repeatability and reproducibility is a method to define the amount of variation, okay, in the measurement data to do the measurement system itself. Okay, so repeatability, we have first R here, refer to the same operator, same part, and then the same device. But another R is we call it reproducibility. So O here is a refer to different operator, maybe the same part and then the same device. So if let's say you want to do the gauge, maybe you want to assess, okay, how well the measurement system can distribute between the part itself. Okay, and then we want to whether the operator measure them consistently, because this part is a crucial Since if let's say your data is not reliable, it might be effect to your process stability or process capability after this. So might be figure out measurement system is maybe the first step before you go for the SPC part or SQC part after this. Okay. So for this case, maybe you have a part here. Okay, we have a 10 part. Okay, and then from the part 1 up to part 2, so we call it this one a part to part variation. Okay, and then you repeat for the 3 times. You have a 3 operator. Okay, you have 3 operator. So every operator repeat for 3 times. Okay, and then we have we call it reposibility, different operator here. Okay, so the first operator repeat for 3 times, repeatability, okay, by the same operator. Reproducibility is different operator, operator 1, operator 2, operator 3. So the different operator here. So this one is coming, we call reproducibility. Okay, when the same part, okay, the same part measured by different operator. So might be triggered to R is a repeatability and reproducibility. O here is a different operator. Maybe the keyword to different between repeatability and reproducibility. Okay, so we have a 10 part. Okay, we have 3 operator. Every operator repeat the 3 times. So we have a 19 runs for this case. Okay. So for the reposibility, we divide by operator and then operator by the part. Okay. So in the Minitab, actually we have how to create the gauge worksheet before you run the experiment. Okay. So I think I go to the Minitab. Okay. So in this Minitab, actually where you can get the gauge R&R or where you can get the measurement system analysis. So of course in the stat menu. So you can go for the stat menu and then you go for the under quality tools. Okay, under quality tools. Okay, and then you can see the gauge study. So in the gauge study, actually you can see we have the create gauge R&R. And then we have a gauge run chart, we have gauge linearity and bias study, we have the gauge R&R. Also, we have the type of the gauge R&R. Okay, we have cross, we have nested, we have expanded. What is the cross, nested, expanded? I will explain after this. Okay, and then we have the attribute gauge study, and then we have create the attribute agreement, and then we have the attribute agreement analysis. I think all these tools available for measurement system analysis in Minitab is almost 10 tools are available in Minitab. So hopefully you already use one of these tools for the measurement system analysis itself. Okay, so we go for the how to create the worksheet before you run the analysis. So how you go for the stat, go for the quality tools, go to the gauge study, and then you choose the create gauge R&R worksheet. Okay, gauge R&R worksheet. So in this dialog box also have the same factor. The first is how many parts you have. Okay, so basic, the default setting here, we try with the 10. So if let's say you have more than 10, so you can go for this part. And then of course, you can rename the part name. Maybe you have a series numbers for each part, or you have the something like labeling on the part and so on. So you can rename on this part. And then of course, you need have your operator to do the measurement. Okay, so maybe you have a 3 operator, so you can rename the operator. Okay, so maybe here is E. Okay, maybe here is something like E. Okay, maybe here maybe is a Kelvin. Okay, so you have 3 operators. So if let's say you have more than operators, so you can go further here. Okay, so but today I just proceed with this one. And then how many replication, how many times of operator repeat on this one? So maybe you can go for this one, 3, okay, and then you click OK. Okay, so now you get this worksheet. And then here, maybe you put the response. or measurement. So here is something like, we call it the worksheet. Okay, you prepare this chat sheet, maybe form or whatever the name for this sheet. Okay, but in the Minitab, we call it, this one is a worksheet before you run the experiment. Okay, maybe I will go back to this one. You can go for the option. Maybe you want to know, do not randomize. Maybe you want to randomize order run, or maybe you want randomize with the operator, and then maybe you want to have standard run order in the worksheet. So actually, this one is, let's say you have already have the worksheet, and then you can insert the data set in this one, and then you do the analysis. Okay, but if let's say you want to create the worksheet, so we able to do in the Minitab side. Okay, so how we repeat stat, go for the quality tools, go for the Gage study, choose the create Gage R&R study. Okay, so you can complete all this one. Okay, so we continue again with this one. Okay, so already done. Okay, so this one. Okay, this part is we have a 3 type analysis for the Gage R&R in Minitab. The first, I think almost of us using this type of the analysis is we call is a cross. Is where cross is the each operator measure each part. Okay, so all the operator measure all the part. So we call this one is a cross. If let's say you have the each operator is unique, no two operator measure the same part. So you have classified this operator measure part 1 up to part 3 only. This operator, second operator maybe measure the part 4 up to the part 6. So this one is, we call it nested. Okay, or something like you not able to have another part. Okay, you're not able to measure another part. So this one is, we call it nested. Okay, so if let's say your situation, your measurement is like this one, so you're able to use the nested. And then we have another way, is we call it is expanded. Okay, expanded is have more than 2 factor. Just now we have the operator itself, we have the gauge, and then the part. Maybe you have another thing, something like the length. Okay, the length you measure from point A to point B only. Okay, maybe point B to point C. So it's something like location. You added another factor here. So maybe you can go for the expanded. So where you can get this all in the Minitab. Okay, so we go to the start menu, go to the quality tools, go to the Gage R, and then you see, which is the cross. Okay, and then you have a nested, and then you have the expanded. So we have 3 type of the Gage R&R in the Minitab. Okay, but today I will focus on the cross only. Okay, if let's say you have more interest on this, you can email me. We give the information on this nested and then the expanded one. Okay, so we go back to this, and then this one. Okay, so this one is a one example here. Okay, we have for the case study for today webinar is we have manufacturer of the fuel injector nozzle installed a new digital measuring system. Investigator wants to determine how well the new system measurement to the nozzle. They could the 9 nozzle. Okay, so nozzle in this case study is a part. Okay, to identify the measurement taken each nozzle. Okay, each operator repeat the process twicely. Okay, 2 times for every part operator repeat for 2 times. So total up will be 36 measurement. Okay, so the specification for this nozzle is a 9012 plus minus 4 microns. The tolerance is 8 microns. So we have this one. I go back to the Minitab. So this worksheet is a nozzle. Okay, so in this worksheet is have a nozzle, is something like our pipe. Okay, they call the nozzle. This one is operator. They have a 2 operator. Okay, so every operator repeat for 2 times. Okay, and then this one is a run order. So all this experimental is a 36. And then this one is the measurement. Okay, so they call it the measurement. So for this case, each part measure by each the operator. Okay, so come to your mind now is the cross. Okay, so how to get? Go to stat, go to the quality tools, go to case study, you choose the cross. Okay, for the part, of course, is nozzle, operator, measurement is a measurement data or diameter. Okay, and then maybe you can have an option here. Okay, maybe you have a lower spec. This one is 8. Just now we have, and then you click OK, and then you click OK. So now you get the output for the GR&R. So I will do, go to stat, go to the quality tools, go to the gauge study, you choose cross, okay? And then you choose the nozzle, you choose the operator, diameter, and then you click OK. So you're able to see the output for the GR&R. Okay, of course, a lot of information you can get from here. Okay, so the first thing, maybe you need to assess on the ANOVA, which is refer to your factor. Just now is a part, your operator, and the interaction. So interaction here is a nozzle, a part by the operator. Is it more than, p-value here is a more than 0.05, so not significant. Okay, so that's why Minitab will generate another ANOVA table here. So for this case, you can see the part itself is significant, and then for the operator itself is the significant for this case. Okay, maybe you have a look another thing. Okay, is it the measurement itself as acceptable or not acceptable? So I think this one, I go back to the Minitab side. Okay, already done it. Okay, so this one is how to interpret, since a lot of information you get from the Gage-R&R. So I will try simplify this output. Okay, in this term. So we have the Gage-R&R table here to assess the variation. Okay, maybe you have a total Gage-R&R, you have a repeatability, you have the reposibility, and then you have the part to part. Okay, so all this one, we look on the percentage contribution, we look on the percentage study variation, we look on the tolerance, and then maybe we look to the NDC. So others, maybe different company have different practices, but in Minitab, we provide all this value. Okay, and then we have, maybe you want to see on the graphical information. Okay, maybe the same information you get, just different visualization. Okay, here is a variation we'll see on this one. And then another thing you need to consider before you go interpret all the result from the Minitab itself, you need to use, I think all of you know, is the AIG standard. Okay, AIG is Automotive Industry Action Group Guidelines for Measurement System Analysis. Okay, so for example, if your percentage contribution is 1 or less, the system itself, the measurement system itself will be acceptable. If let's say 1 to 9, potentially acceptable, but maybe have something like depends on others measurement, something like measurement itself, cost and risk and so on. And then if let's say your percentage contribution is more than 9, okay, the measurement system itself is not acceptable. Or maybe you can go for the percentage tolerance. After that, you can go for the standard variation. Okay, and then maybe you can go for the standard process. For all this guideline is from AIG standard. Or maybe you can look on the NDC itself. So if let's say NDC 5 or more, so we also AIG also say that it's acceptable. And then this measurement is distributed between the part. Okay, so if you look on this tolerance, okay, study variation and the process, under 10% is acceptable. 10 to 30 is potentially acceptable, and then over 30 is not acceptable. Okay. So for this case, we already done it for ANOVA. So we look on the Gage R&R, okay, Gage table. Okay, in this Gage table, you see the total Gage R&R here is 0.80. Okay, this one is a repeatability. Total Gage is referred to repeatability and reposibility. And then you have the part-to-part of variation. And then total up from the total Gage plus with the part-to-part, you can get the total variation here. Could be is 100. So based on this part-to-part is higher than total Gage, so we consider that this measurement is acceptable. Okay, so maybe you can look another thing, something like maybe you can go for the percentage variation. So for this case, is total is less than 10. Okay, and then this measurement is more on the repeatability, not the reproducibility. So you look on this value, repeatability more than reproducibility, and then your NDC also is more than 5, so even 50. So we consider that this measurement is acceptable. Okay, and then maybe you can proceed to others analysis or others data collection. Also, you are able to see in graphical. Okay, so for example, you want to see on the bar here, and then you can see on the control chart here. Okay, control chart, since all this in the X bar are chart, all the part, okay, all the part is a more than control limit. So we consider that it's a part-to-part variation more than total Gage. Okay, so you can see interaction is more interaction here. So all different operator is not quite different, and then each operator have the same measurement. Okay, so the same, we have a two operator 2 times. So every operator have not have so different between observation 1 and then observation 2. Okay, so the operator seems to be measure part the similarity of the part. Okay, so you can see on this all this information. Actually, this one, something that one. So this one is a Gage R&R here, contribution, and then you have a Gage evaluation. So let's say for example, your part is a less than a total Gage more than a part-to-part. So might be trigger up this that one, the measurement is not acceptable. So if not acceptable is coming from repeatability or reproducibility before you get the root idea or root causes to capture it. Okay, maybe from the reposibility. So if let's say reposibility is from the different operator itself. Okay, so you can look on this one and then this one. But if let's say you want to see one by one, okay, one by one graph, maybe more bigger rather than this graph, you can go back to dialog box and then you can go for the option 1, and then maybe you can draw graph on separate graph or the part, which is, and then you click OK. So if let's say here is your study is something like this one is a 6 sigma, maybe you have 4 sigma and so on, you able to edit in this option 1. Then you click OK. Okay, and then you click OK. So okay, this one. And then other thing is what is the method of analysis. Okay, if let's say you look on the, you choose ANOVA. Okay, Minitab will generate ANOVA and then X bar. But if let's say you choose the X bar chart only, so you're not able to see the ANOVA side input. Okay, so for this case, maybe you just default setting by the ANOVA and then you're able to see a lot of information on this one. Okay. So I will just recap again. So why we use the cross, since every operator measure all the part, okay, not the different operator for all the part. We have the 9 part, okay, 9 part. We have a 2 operator operator repeat for 2 times for every part, and then you total up for the run is the 36. Okay, so how to get? Go to stat, go to quality tools, go to stats, and then you choose the cross. Okay, why we choose the cross here? Okay, so we'll continue again for this case. Okay, so we have for the Gage R&R, actually we measuring is something measuring. For this case, for this example, we measure the diameter. Okay, we measure the diameter. So in mine now, diameter is continuous. Something like you have an attribute. Okay, you have attribute. Okay, you have attribute. Okay, you have attribute here. So attribute agreement analysis also we call attribute Gage R&R. Okay, attribute data are usually collected when the standard measurement are difficult to obtain. So maybe one part you not able to come out with the measurement, something like length or diameter or something that one. So you try convert that all the information to the something attribute, or we call it text data, something accept or reject, something that one. Okay, or maybe you have a level 1, level 2, level 3, level 3, or you have a rating, something like rating 1, rating 2, rating 3. So the same thing, you want to see on this attribute agreement is to evaluate the agreement of subjective nominal rating or subjective ordinal rating. So what is the nominal rating? Nominal rating is something like categorical variables, okay, that have multiple levels of characteristic with no nature ordering. So something like low, high, medium, something that one. Okay, you okay, sorry, low, high, medium is something like ordering, something like you that doesn't have any ordering. Ordering is something like we have a level of education, we have the primary, secondary, diploma, and then we have so on. Okay, so this one is for the nominal data set, you have no ordering. If let's say we have another way, is we call it ordinal. Is a multiple level also, okay, but with the ordering. So you have a rating, rating 1, rating 2, rating 3, rating 4, and so on. So you provide the rating. Okay, you convert from the, maybe you're not able to do the measurement. Okay, you're not able to get the something like 5.1, 5.3, something like one. You're not able to get, but you have a rating. Okay, you have a scale for the rating 1, maybe scale 5.1 up to 5.3, so rating 1 and so on. So you have a ordering, whether it's something like 1 is a good or 1 is a bad or something like one. So if you have faced with this situation, you are able to do the Gage, but have, we call it another tools, attribute agreement analysis. Okay. So for example here, okay, for example here, we have one case study here. Okay, the fabric appraiser at the textile printing company rate the print quality of the cotton fabric on the 1 up to 5 point scale. Okay, so in mine now, 1 to 5 is something like rating. Okay, the quality engineer wants to assess the consistency and then the correctness of the appraiser's rating. The engineer asks for appraiser to rate print quality on the 50 sample of the fabric twicely in random order. So mean to say that the rating, the answer can be 1 to 5. Okay, maybe they have a 4 appraiser. Appraiser A maybe say this part is 1. Appraiser 2 maybe say this part is a 3. Okay, something like this, that one. So that one, they want to assess on the consistency and then the correctness of the appraiser rating. Okay, so we try, go back to the Minitab. Okay, for another, this one. Okay, this, okay. So we have, we have the appraiser. Okay, we have a 4 appraiser here. It's a mic, maybe, and then we have the response. Okay, and then we have the sample, the part here, and then here is the trial. Okay, and then so every part they have a 2 trial. Okay, and then this one is the standard. That part is should be have 5, but this might evaluate is a 5. Okay, maybe others operator maybe not 5, maybe others rating. So this, if let's say you face it with this situation, so you're able to use the Minitab, but in different attribute agreement analysis. Okay, not able to do gauge study, but in the attribute agreement analysis. But for this case, before we go further on this time, we need to know this one is a more than, okay, sorry, we'll go back to this one. This one is a more than 2 response, okay, more than 2, 1 up to 5. If let's say you have a 2, the output may be different measurement only. Okay, different matrices. Okay, the step to explain or to interpret is the same, but just only different matrices. Something like before this you have a CPK. Okay, you have a PPK, something like one. So for this case, for the attribute agreement analysis, if let's say you have only 2 binary, okay, only 2 response, accept or reject, your yes or no. So maybe have a different with this case study. Since this case study is a rating, the answer can be 1 up to 5. Okay, more than 2. Just only different matrices. I will show after this. Okay, for this case, we try with the attribute column here. Okay, the sample, the appraiser. Okay, so here is the response. Okay, so the sample is our sample, appraiser of appraiser. So here we have the standard. Okay, we have the standard. We have the standard here. Okay, for this case, we have the ordered. Okay, we have the ordered 1 to 5. So you just click on click OK, and then you click OK. So now you get the output. I will go to start, go to the quality tools, you choose attribute agreement analysis. Okay, so the response attribute column is our response. Okay, your sample, your appraiser. If let's say you have a standard, you must include the standard. If let's say you have, because this portion is optional. So if let's say you doesn't have standard, you able to run the analysis. And then for this case, we have the category. Then click OK. So you get this. Okay. Seems with the Gage R&R, you have a lot of output. Okay, you have a lot of output here. The first is, we call it reading appraiser. For this case, we have 4 appraiser. Okay, we have 4 appraiser here, Amanda, Brit, Eric, and the Mike. So they inspect for 50. And then the mesh with the standard, okay, for the Amanda is 100. So the last standard here, the last number is the Eric here. It's something might be not good for the Eric. Okay, Eric evaluate only 43 out 50. So only 86% they correct for the Eric. And then we have another way is we look on the kappa value, kappa coefficient. Based on the AIG standard is, let's say 0.75 is a good. Okay, is let's say you get go more than 0.75 is a good for the kappa value here. Maybe look on this kappa value for this Tracy kappa statistic. Okay, so you have the candle also for the candle here. So you also have the coefficient here. So Amanda is the good one. And then you can look on the appraiser versus the standard. Okay, so you versus the standard, you can see the percentage here. Eric also is not so good. okay, between the measurement and the standard here. And then you can look on the kappa for every response here, okay, for every kappa here. So kappa is something like 0 up to 1 is 0.75 is okay, okay. And then the area you see, this one, below than 0.5, 0.75. And then you have this one. And then we have another between appraiser itself, okay, between appraiser. So inspect the mesh out of this one. The candle is this kappa, this value. And then we also have the all appraiser versus the standard. And then we have the mesh with this one. And then we have the, maybe you look on the kappa value and then with this one. Or you want to have something visualized on this case. Okay, for this case, you can see the within appraiser. Okay, between appraiser itself, you can see Eric. Okay, Eric have the lowest percentage. Okay, and then for this appraiser versus the standard, Eric also has something not good for this case. Okay, so you can look on this one by one. So I will try to look on this one. The first, evaluate the appraiser agreement visually. Okay, so we try with this one. So within the appraiser graph, indicate that Amanda has the more consistent rating. Okay, Amanda, this one is a less small line. Okay, and the Eric has the less consistent rating. Okay, so for the appraiser versus the standard graph, indicate that Amanda have the most correct rating and then Eric has the less correct rating. Okay, so all goes for the appraiser, the consistency of the response for each appraiser. So here we say that many of the kappa value is a 1, okay, indicate the perfect agreement with then and appraiser between the trial itself. So Eric rating have those sample were inconsistency. Okay, so since this one, they provide the candle coefficient. Okay, so Minitab provide the candle coefficient. After this, you try with your data set with the binary, Minitab not give the candles coefficient. Okay, Minitab give the different coefficient, different matrices. Okay, so where this value are greater than 0.98, okay, which indicate a very strong association within the appraiser rating itself. Okay, so we go for another appraiser, assess the correctness of the response for each appraiser. So we look on the appraiser versus the standard here. The same, we have the candle coefficient, this one, which is, we also that this one is associated between the rating and the standard value. So we look another appraiser. So we look on the between appraiser here. Okay, so we have all the appraiser large, okay, the 0.77, and then the candle coefficient coordinate here, which indicate a very strong association between the appraiser rating. And then here is assess the correctness of the response for all the appraiser. So you have this value, then you look on the candle coefficient of coherence. Okay, so it's a strong association. And then this one. So all this for the measurement attribute analysis, maybe you see similar value, but the assessment on this have different. For example, here is a within appraiser. This one is each appraiser versus the standard. Okay, and then this one is a between appraiser, and then here is all appraiser versus the standard. So all the output is look like same, but if different assessment. Okay. Go back to this one. So how to get, go to stat, go to quality tools, go to attribute agreement analysis. Okay, so you might complete the dialog box and then you click OK. So you're able to see on this, all these things. Okay. So we go back to the, this one. Okay, so assistant. But for this time round, okay, we have another 10 minutes only. So we show on the Gage using the assistant menu. So as let's say you are the or user of the Minitab, you're able to see the assistant, or maybe you already use the Minitab. Okay, but here I just want to give the information have some limitation for the attribute agreement analysis. Okay, we try. Okay, we try for this case. Okay, we try the same data set, which is nozzle case study. Nozzle case study. Okay, so we have a nozzle case study. Just different way to get the result. Okay, so you go for the assistant. Okay, assistant, you see measurement system analysis. Okay, for the stat menu is under quality tools, and then you see under Gage R&R. Okay, or so on for this case. But in the assistant, they call measurement system directly. Okay, so go for the measurement system itself. Okay, so you see we have measurement, we have the appraiser. So if let's say you're not sure, okay, so you can go back to this information. What is a measurement? What is the appraiser? So they give it you the example here. Maybe your data set is the appraiser. So you look on the appraiser. Okay, maybe you won't go for the objective. What is the example analyze? They give it the example how to run. What is by the analyze appraiser data set. So they give it you this information. But for this case, it's measurement. So we go for this side, measure. And then you already have the experimental data. So you might go for the cross only. So for the operator, is operator. Parts is our nozzle. Measurement is type meter. So maybe estimate for this case. So if let's say you have a historical, so you can go for this historical. Maybe his tolerance is at 8. And then you click OK. So now you get the result for Gage R&R using the assistant. The different, maybe have different presentation. Okay, different presentation. Okay, but the information stay the same. Okay, just different graphical or the visualization to do the reporting purpose or so on. So go for the assistant management system, and then you go for the analysis. So you might complete all this information for the dialog box, and then you get. But I think the best thing for the assistant, they give it you this. Okay, can you execute the access process performance? So this one is the green color here is the yes. So they give it you the result directly. Okay, but they give you also something like is a good, and then you have a variation here, same hour with this one. Okay, for this case, we have the total gauge. Okay, and then we have the repeatability, reposibility. So for this component of variation, we have the total part to part, repeat, reposibility, and the gauge. So for this case, they not provide the part to part, just only the variation of the sources. Okay, and then you have a comment here, and then they have a variation report here. Something that one is the same. Okay, so for this case, also the same. Okay, the sources of this variation also this one. Okay, this case. Okay, so might be the one. And then another thing for the assistant, they provide you the report card. Okay, the report is something like what we need to measure, we look before we do the analysis. Okay, for the report card, actually, they give you some information. Okay, before you rely on that result. Okay, for the report card. Okay, so the just different way. Maybe you can go for this method, this way, or you can go for this way. Okay, but here, is it? You go for the assistant, you go for the measurement system. For the analyze, is a limitation. For the assistant is just only for binomial cases. Okay, just only have a two respond. Okay, 2 level. Is accept, reject, yes or no, 1, 2. Something that one only. If let's say for this case, okay, for this example, we have a 5 rating. Okay, so you're not able to use the assistant. Okay, you're not able to use the assistant to get the result. Okay, so you must be use the stat menu. So go for the stat, quality tools, go for the go for the attribute agreement analysis for this case. Okay, just your information. Okay, because a lot of customer, After they know about the assistant, so they always use the assistant. But for this case, on this study, for this analysis, have limitation for MSA in term attribute agreement analysis, only for 2 response. Okay. Go back to the, okay. So already done it for this one. Okay. So if let's say you have a question, please type them into the question box. Okay. I think I need to say the, is it we not enough time? No worries, you can drop the question in the question box. I will email after this. The answer I will answer it by the email. Okay. So you can drop the question into. Okay, I have a question here. Is it compulsory to number of a part 10, number of the operator tree and the replicate the tree can be less than that? Can, okay, but for Minitab just is a default setting. Okay, default setting. But we say that for the replication, maybe the best thing is 3. Okay, for the part also, maybe the best thing is of 10. No worries for the Fizudin. I will email to you something like case study or something like information more on this part. Okay, I will email if let's say you want have more on this part. Okay. Okay, if let's say you want this this slide, you can drop your email in the chat box or Q&A box. Okay, you drop your email. I will email after this. Okay. You can drop your email. After this, I think a lot of question you drop. I will email to you after this scan. Okay, sorry for that. We're running the time. Okay. Okay, so no worries if let's say you want more and then you still is not enough with this webinar. We have something like others event. Okay, this one is our training part. If let's say you want to more on the gauge measurement system, we encourage you join our training for the Minitab level 2 training. We call statistical quality analysis. But beside the measurement system system analysis, we have others other study, other tools in this module. If let's say you want to more, you just scan barcode here to find the more on this one. Okay, and then we have this one. We had this event. This one is a free event, but on the 23rd June. Okay, if let's say you are interested, maybe this event more comprehensive. Okay, we cover all this linearity and bias. I think a lot of our customer ask about linearity and bias. Okay, and then maybe have something like sharing from the expertise from the links in my master black bag. Okay, if let's say you are interested, we will email to you, okay, the information regarding how to register and so on. And then maybe you can stay up with our social media. We will update all this information for this event. Okay, hopefully you can drop your email for us to ask the expertise for this case. Okay, so maybe I will see you on this event. Okay, hopefully we can see you this event. Okay, so thank you guys for your time and attention. And then I will feel sorry if let's say I cannot answer all the questions in this webinar. I will email to you after this. Okay, so to learn more about this product, not the only Minitab statistical product, statistical software, maybe others, something like Workspace, something like Engage, and so on. So maybe you can visit our website www.minitab.com or www.visit.com, or you can email us to sales@visit.com. or you can email us to minitab@visit.com. Okay, and then please follow us through media social, something like you want to know more event from our regarding the Minitab. So you can follow us through the Minitab Malaysia and Singapore through media social, Facebook and link Minitab Malaysia and Singapore. So we not only have a training, we not only provide the license, and then we also have the something like service statistical consultancy, and then we have the support. Okay, support not only the how to install the software, maybe support something like how to get the SCB agreement lists, how to get the other tools are available in Minitab. Okay. So really appreciate if you can fill out our survey in order to enhance our webinar session. So see you next time with different topic and stay safe.